This time, I'm on time. Hey, my name is Alex, and welcome to Redstone Weekly. Today, most of the market team's out, but we'll be able to see what our teams are working on in terms of the robot.
Right now I'm working on the bumpers for the chassis, and we just got all that wood cut out, and we're gonna start putting it together right after this.
For the newbies, can you explain the bumpers and the importance of the bumpers and what they do?
So we have to have the bumpers to keep other robots safe and to keep our robots safe. They're essentially just, if we do them like other years, it's wood that gets put on the side of the robot with usually what do we use, pool noodles and then cloth to show which alliance we're on. It'll be blue or red. And we usually have Velcro so we can tear it off quicker and change our alliance colors really quick if we have to get right back into a match. But it's pretty simple.
Yeah, so right now there's two current intake teams working. So one is working on pneumatics, which is me, and the rest of the team is working on a motor system for the intake. So yeah, it's down here. Then it would extend up like this. Then it would just retract back up, pushing the piston down so it would fit into the frame and over.
So after today, what are you going to do going forward?
We'll probably refine it because it's not perfect right now because we had to change these plates out to aluminum.
Was working on pneumatics. We were continuing to work on the motor design in case his doesn't work, which hopefully it does, so we don't have to continue with this. Yeah. But with the problems with the thinner pieces, it was very wiggly. And so with the thicker pieces, we can put more churros and more supports and stuff. But it's basically the same thing as the little pieces, but bigger and hopefully more stable. So
this one would go up and down like this. It's very similar to that, and you'd have just like the climber, it would have a spring in order to make it go down, and then there'd be a rope to pull it back up. So the thing that's unique about this is that typically all our bearings are 1 inch and 1/8.
Yeah.
And so it doesn't fit in a 1-inch tube. But if you use 3/8 inch hex, there's some special bearings that are 7/8 inch, so it does fit. So it'd be way lighter. Once I think the measurements are worked out, we'll have a team work on that, if it makes sense.
Okay, shooter turret.
Let's go up here. So, last week, I'm working on a design just to make that shorter by taking just 2 of these and stacking them on top of each other.
Why did you want to make it shorter?
So that the ball doesn't get stuck after it comes out of the hopper. And the wheels are just lower, so it catches the ball easier. But after we made the shorter version, we put it on the turret, and not that one, a different one, but it wasn't square, so we had to go cut out new pieces to make it square. Here in the front, I had to cut out or mill out a section here so that the wheels didn't get caught on the bar on the bottom. But other than that, it's pretty much the same design as the last one that I worked on.
So where are you going to go from here for the rest of today and into next week?
Just trying to mount it and see if it works the way we think it's going to.
So it looks like TJ has a hopper structure in hand behind you.
You want to explain your idea, DJ?
Yep. So this is the hopper design version 2. Changes that we've made from our last hopper is we added bevel gears here, so we'll have extra space on the sides, and we added more screws on the mounts, so that way it will be more sturdy. Basically all I need to do now is cut out this inner part so that the game piece can actually come through here without any interference. for mounting, the shooter is gonna go on top of here. I think the one thing we need to work out is clearance between the two sections because we had trouble on the last design. So I think we need to work that out, and that's it. So another change that we did is we moved the mounting holes for the bottom over a couple inches, so that way we'll have room for climber.
And also raised it 3 inches in order for electrical to all go underneath.
Yeah, we did that too.
So where are you gonna go for the next week and the rest of today?
So for the rest of today, I think it's just working out clearance, and cutting, and finishing. For the rest of the week, I think that's where we'll hand it off to electrical and programming.
For the climber, since last week, we made a more sturdy version and we added 2 more pneumatics because we didn't think we were going to be able to lift enough weight with only 2. And we added 3 more tanks for air so we can hold more air and use them at the same fuel. And we still need to add the arms to the side of this for arms that will reach up to grab the high bar, and then that's pretty much it.
You figured out your fit issues on how to get it to fit?
I was just about to ask, you know where all this stuff is gonna go?
Yeah, we still have to figure out how to fit it on.
Okay. How about the angles as far as perimeter and how?
No, we haven't figured that out.
Okay.
So then where are you gonna go for the rest of today and the next week?
Yeah, we're gonna figure out how we can get it to extend the next bar without going outside the length limit in front of the robot, and how to fit it on the robot itself.
Do we have someone else working on the other climber? Okay, so
Last week our test was successful, but we had a lot of like stability issues. So we redesigned it using CAD, but today we found out that that CAD model just isn't working. So mechanically we're moving on to building the motorless climber from the everyday bot. And going into next week, we'll be redesigning our linear lift system so we can build it. But realistically, we don't have any like dates for when it should be done.
Couple days we've been sorting out color coding with the turret, as well as right now we're planning out the controls for the how the robot's going to work. So we planned out, first we were thinking that we just put like spots of tape at the north part of the turret, northeast, west, east, and so on. So we then realized that if the robot were to wake up and land on just a part with no tape on it, since there are multiple of those, it wouldn't be able to tell where it is. So instead we switched to a system in which there's always a piece of tape covering it except for one spot that's blank, but it can just recognize that as an individual color. So that way the robot can know where it is at all times on the turret. And right now we're working on controls, so we have some of the controls working. I think after lunch we're going to be planning out a more organized control system, so that way we can have a better controller 1 and controller 2, one for drive, one for mech. And yeah, that's what we're working on.
So, well, this is my first time saying something. This is what turns it on. It's like the black switch. And then the only like small issue I'm seeing right now is that this could be like really squished or like mess up these wires. So I would say to add more room, especially right here just a little bit. We will be making more canvas, so that connects everything. We do need more of that. I know last time when I was helping wire it up, some people were talking about moving motors around. Yeah.
Just let you know with version 2, it's probably all going to be underneath. So you can pretty much just flip the robot 90 degrees and it's all right here. So it'll be a little bit easier.
A little bit easier, it probably will be.
So then where are you gonna go from here for today and the rest of the week?
Well, for today, we're just waiting on whoever else needs their stuff wired up, and then I'm still learning the basics, so, and making more canvas wire, probably.
I want to point something out since we have so many new people here. Does everybody know what this thing is? Okay, this is important for those of you that are new. For those of you that are here already and already learned to ignore it, that's a bad thing. It's a bad thing. We call this the idiot light. It's actually called a robot signal light, and it's very important. When you see that it is on, it means the robot is turned on. If it is flashing, it means stand back. The robot can move by itself at any time. It's very important that you pay attention to this. Everybody got it? What do we call this?
Idiot light.
That's because if it's flashing and you get run over, it's the idiot's fault. Okay, we're done.
When working on the robot, if we're trying to turn it on, we need everyone to stay back. So that's
Yeah.
basically what it is.
And if you're working on the robot, a couple of things, turn it off.
Turn it off.
Don't work on it when it's turned on. Don't drill on the robot, and make sure you know where your shavings are going when you're drilling. If they're going all over the electrical board, we're going to be upset with you. The electrical group is also known as the shoehorn group because we always get the robot last and have to shoehorn all the electrical stuff into it. As you move things around, we need to know so we can get things rearranged. Yeah. So the next robot will look even nicer. So we know what this is. It's powering up all the stuff that's on the turret, so when the turret turns, it doesn't rip any of the wires out. You can use the turret more than once. That's it.
You're still relying on the programmers now.
Well, if they do that, it's out of my control.